So after you've logged in, this is what you should see. And you may get these pop-ups for different tutorial pieces, different helpers. You can go ahead and close those because we will not be using those. If you look across the top of across the top here of your browser window, you'll see the main menu pieces here: the databases, shares, the marketplace, warehouses, worksheets, and history. We will spend a lot of time in the worksheet section. We'll also be hitting up database and warehouse. We'll hit share a little, but not a lot. But our big areas will be the databases and the warehouse and worksheets. Excuse me, for some reason I have a yawn. Sorry about that. I don't have a dump button, so couldn't take that out. All right, you'll see over here on the left-hand side, there are some files or some pieces already in your 30-day trial. We're not going to be using those much. We'll hit the Snowflake sample data piece just very briefly toward the end. The rest of this, we're going to create our own stuff, so we're not going to need that. It looks like I already have this worksheet loaded in mind, but we're going to get you there. Okay, so the first thing that we're going to do is have Tim get on track to the right place. And the first thing we really need to do is, if you come up here, you're going to see some little buttons along here. There should be a triangle down here. So get me to the right place. Need to load my script. So if I click the little triangle, I'm on a different size monitor now, and my buttons have actually moved across the screen. So the little triangle here, if you'll open that up and go to load script, and then navigate to wherever it is that you saved the file called lab scripts in-person ZTS SQL, or whatever you called it as you saved it. You're going to need that one. Open that up. All of the SQL statements that we will be using are in this script. You do not want to take the, if you downloaded this as a PDF file, you don't want to copy and paste the SQL statements in from the PDF file. That messes with the formatting of them, and they won't run. You'll get error messages left and right. So save yourself the headache and import the file. If for some reason your computer has settings on it that won't allow you to do this loading of this, you can actually bring that into a text editor like Notepad or Notepad++, and you could copy and paste them in from there, but don't do it from a PDF. Okay. So that was my one thingamabob there that we had to be really careful of. So there's a story to go with what we're going to be doing here. I guess I should finish showing you things in the UI first, though. We have history, and there'll be many times when we want to go back and take a look at history. My history is got a lot more stuff in it than yours. I have actually gone through this a couple of times, so my history has more there. You'll want to look over here to the right-hand corner, and you'll see Tim, and you'll see sysadmin below for me. Yours will have whatever your user account was that you signed up with, but you will default also to sysadmin. That is the default here. If you're in a real-world situation, not everyone's going to be sysadmin when they log in. The admin is going to be creating accounts that give certain people access to the things that they need to do their work, and that's it, and that's all part of our governance and security model that we spoke about earlier. So you'll see in here you could change your password, switch your role. We will switch our role later. There are some preferences you can look at. Be sure to go back through this on your own. I'm not going to spend a lot of time in all of this because we frankly don't have that much time. I could be happy to spend a whole day in here and play with different things and see how things work. And that's, I guess, the whole purpose of having the trial account. So later on, you can bring in a set of data if you want to, that's all your own, and see what you can do with that data. Just all kinds of great things to do. So I'm going to click on the Snowflake button over here in the left-hand corner. And by doing that, I'm going to come back to this main screen where I've got my objects or things here on the left-hand side showing me my, in this case, well, my worksheets here in the middle. So we're going to get started on this here. Now, the story here, because everything's easier to do when there's a story, right? The story of the lab is based on an analytics team at a company called City Bike. City Bike is a real citywide bike share in New York, New York City. Um, the team wants to be able to run analytics data and to better understand their riders and how to serve them best. So we're going to start out in the first part here, and we're going to load structured data to begin with. So we will actually be loading data from the real company called City Bike. We'll create the database, we'll create tables, we'll create warehouses and all that good stuff. And then after we've got all of the structured data in, we're going to bring in some JSON data that's weather related. And we're going to just look and see, does the weather have a direct impact on the number of people that use the rideshare service for City Bike? And that's the question that we ultimately want to answer as we get through this. I really have to apologize. I have no idea why I keep yawning, but it's quite distracting to myself, and I'm sure it's not so great for you either. So the data from the bike share data is it's a CSV file and it's in AWS S3. So we'll keep that in mind. It's 61.5 million rows. There are 377 objects and 1.9 gigabytes of total size compressed. So I'm not sure what that is uncompressed, but there's plenty of data here to get something of a real world look at how this goes. All right, so we're going to start out by creating a database. And the first thing that we're going to need to do is go over to the menu on the top to the far left and click on databases. And then we're going to click create. And for the name, we're going to call it City Bike. It's CITIBIKE. You do not need a comment and just click finish. And then you should see down there, we now have City Bike as a database created at 2:23 p.m. So we are off and rolling at this point. So let's go take a look at the worksheet. So click on worksheets at the top. Okay. And you'll notice here we have the all of these different scripts are all lined up here, and I want to show you something, but I need to correct something in my world first. We have a context here, and my context is still set to account admin rather than sysadmin. That's from my last run through, and I didn't get that set back. So before I go any further, while I see that on the corner of my eye, I want to fix it up. So I'm doing the same thing you're doing. So if you take a look at the script file, each section that's in the hands-on PDF with its screenshots and narrative, um, they're all called modules, and the modules are all highlighted here in the text. And then you'll also notice that each step in the hands-on guide, they're all noted here as well. So there are a couple of times where we do the same thing that we did before. You don't have to go backwards because literally all the steps are numbered and you just keep going step by step by step through this. Something else I'd like to point out is that when we run a query, you do not have to highlight the entire query to run it. All you have to do is put your mouse cursor somewhere in that query before you hit run. You also want to look at your environment right away and make sure that the box that says all queries is not checked. If that box is checked, this thing's just going to go and run through the whole thing, and you're going to want to reset everything in order to to learn anything. So we want to be careful of that. So fun there. All right. First, we're going to make sure we set the context, which we're going to use the UI, the user interface here for the first part. And then later on, we will, when we get to bringing in all the stuff that's in the JSON file, the semi-structured stuff, we're going to move more to using SQL statements just for the sake of speed. But up here on the menu, this is our context along here. And if I click on any of the pieces here in the context menu, this box will pop up. And we want to make sure before we run our first query that we're looking at compute warehouse. Now, that warehouse was already created, and we'll talk about that. That was there when we started. We're going to choose the City Bike database that we just created, and it's located in the public schema. All of our work's really going to be in the public schema. So you want to set your admin in that way. Okay. And now we're going to create a table inside of, we're going to create a table, excuse me, inside of City Bike called trips. And if you look at the very first line, you'll see that this is create or replace table trips. So click your mouse anywhere inside of that query and hit run. Okay, that's pretty quick, 152 milliseconds. If you look at the results pane, you'll see we have a green check mark indicating that it succeeded. It gives us the time. If we hover here, we can see how that time is broken down. And then down below here, it just tells us table trips successfully created. Anybody have trouble getting rolling? Good. Okay. Excellent. Excellent. Well, if you well, I already told you, don't highlight everything because then you've gotta tell it to run and all that stuff, and it just gets to be quite the bother, and we really don't need that. So let's go back over here now. Let's go back to City Bike is here, right? So let's click on database at the top, and we see City Bike. So let's click on City Bike, and we can see that we have these tables, just one table at this point called trips, right? And if we were to click on trips, you can see here all of the column names, what type of data is in the column, whether they're nullable or not, and if there's some default value in them. So we have created the database and we've created our first table. We don't have anything in that yet. So the next important thing is to actually work toward getting data inside of there. We already mentioned that the data is a it is a CSV file and it's stored in an AWS S3 environment. So the first thing that we have to do is create this external stage. We have to tell Snowflake where the data is coming from so that we can get it in here. So if you'll click on stages, and then after clicking on stages, we're going to click create. And this is where we're going to choose that existing Amazon S3 location. You want to do that and then click next. And the name for this stage, this is the name for the stage, is citybike_trips. And remember, city is CITI_trips. It is in the public schema, and our S3 URL is actually listed in the hands-on notebook there, but you can say Snowflake. I can say it a lot easier than I can type it today. -workshop -lab /citybike-trips. Okay, now we do not need to do anything with the key ID in this case. We're just going to leave everything else on the screen alone. We just need these three things, and then we'll click on finish. Okay, so now we have our stage here, and we've got to tell the what am I saying to myself? I have to configure this thing. Where? What have I done? Excuse me while I hit myself for screwing something up. Oh, excuse me. So go back to your worksheet. My bad. Sorry. We're going to go down to the 3.2.4 script and just click on that. We're going to see what's inside the stage. So if you'll click anywhere in that one line statement there and hit run, then you'll see below here in the results window, you can bring that up and down. You can make it larger, smaller, whatever you want to do with it. We can see all of these pieces that make up this stage. Okay, so the next thing, we've got a database, we have a table, we have a stage. Now we've got to have a file format to work with that stage. So I'm going back over here to the database. It's City Bike trips. That should be the highlighted thing, City Bike trips, because it should still be set on stages for you. If you click the very next button, file formats, okay, and then click on create. Okay, so it's a CSV file, so we're just going to name this CSV. All right. And then we're going to scroll our way on down here to the field called optionally enclosed by. And optionally enclosed by needs to be double quotes. So I have a CSV file. If I have text, it will be optionally enclosed by double quotes. I'm going to erase what is on the null string line. We don't need that. And if you'll scroll down further, there's a checkbox here for error on column count mismatch. We're going to uncheck that as well. And just make sure it's called CSV, it's public, the format type is CSV. We're using the double quotes. We uncheck the error on column count mismatch. We got rid of the null string, so we click finish. All right, and now we have a file format to run with our stage that will be bringing data into our table. All right, so we move to number 4, and before we bring things, one thing I should stop and say is that to this point, all we have done is created these objects that we need, right? This work has not cost us anything. So we've created the database, we've created the table, and well, we have run a couple of queries. So, but no, we haven't really done any big deals here. So I don't believe you've used any of your allotted time on your trial account yet, because this work is free. Once we start importing the data and then working with that data, we'll start accruing. So, but we have to have a warehouse in order to start moving stuff. So click the warehouse button, and you will see the warehouse that was already there. Click somewhere on the line so that that line is highlighted. And in my case, it's in blue. And then we're going to click on configure. Okay. Well, you'll notice that by default, when you created the account, at least in mine, it was an extra large. And with an extra large, it tells us we use 16 credits per hour. Well, we really don't need that much horsepower. I mean, but this is where we do that configuring. Okay, so on this screen we can configure the size, and we talked about in the first session the t-shirt sizing. So we go anywhere from extra small to 4x large, and think of it this way: if I have the 4x large, that's like having how many was it? That's, oh, I can't remember how many it is. It's 100. It's like 128. 128 nodes, right?
Yep.
Okay.
Yeah, so it's good for the internal meeting to note this. So notice that every step up in t-shirt size is a doubling of computing power. So 2 credits for a small, 4 credits for a medium. Today, and I say that very loosely because this is changing very soon. Today, a credit is a node hour. So when you create an extra large cluster, it is in fact 16 EC2 nodes of a specific type, and we charge you 1 credit per hour. As the infrastructure cloud providers change their node types, that may not always be the case. However, what we guarantee is that you're getting double the amount of compute for every step up in t-shirt size. So let's assume Amazon rolls out some really awesome GPU powered EC2 instance. We could decide to make the 3 and 4XL GPU backed infrastructure that was not 64 actual nodes of compute, but did give you double the amount of computing power of the 2XL. So, it's easier to think of it as every step up in t-shirt size will double the amount of computational cycles you get, regardless of the number of actual machines in the cluster.
Yeah, and an EC2 cluster is also equivalent to, say, an Azure VM.
Yep.
So if I went 4x large, I'd be getting either 128 EC2 nodes or 128 virtual machines, basically, or virtual, Azure virtual machines.
Correct.
So if I did that times 10, the power is almost limitless here, which is just incredible and something I love. So for the sake of what we're doing here, because we're gonna do something to do this next step twice, and we're gonna look at the difference in this horsepower and the doubling and whatnot. Let's set this size to small, Okay, the 2 credits per hour. And then we're going to leave the maximum clusters at 1. This is that part that Jordan was talking about earlier um, where Snowflake can scale outward on its own. You tell it that the maximum number of clusters that you're willing to have is 5, and it's going to go until the compute power is used up on 1, then it's going to automatically add 2, and then 3. And then as your workload reduces toward the end there, it's going to start scaling that back as well. So you'll go from 3 to 2 to 1 automatically. You don't have to jump in there and help it out at all. Okay, and that scaling policy comes in 2 ways, standard and economy. We're going to stick to standard. Don't ask me for the definition of economy because I didn't look it up, but I will. And then auto suspend because we don't want to burn 2 whole credits if we don't need to. So we can tell it to suspend without being when it's not in use after 10 minutes, 10 is the default. I'm a cheapskate. I always go put it on 5 because I want to use my freebie account as long as I can. And then we check the box that says auto resume so that when workload is sent toward this cluster, it'll kick in without me having to come back and tell it to wake up. Okay. And we'll click finish.
Question, Tim.
Sure.
Is there can you give me an example or reasoning why you wouldn't put the auto suspend on as like the minimum? So at 5 minutes, why you wouldn't just put that on for everything?
Well, the only thing I can think is that there might be just a slight delay in the time it takes to start up. But otherwise, no, I can't come up with a real valid reason. Unless you just like to spend money.
So I can give you the reason why
good.
Sometimes the auto suspend time is set to a longer duration. So, and it gets into the caching mechanisms that are available in the Snowflake platform. I think Tim's going to hit on this a little bit later, but results cache is always free. Results cache does not require compute. So if someone runs a query anywhere in the system and another user runs exactly that same query, compute is not used to calculate the result. It simply returns the results cache. It's free. And that works across compute clusters, assuming that none of the underlying data used to satisfy that query has changed. And the system handles all of that. Now, another layer of caching is at the compute cluster level. So over time, if you have a reporting environment where you're hitting specific sets of data with not using the exact same queries, but very similar queries, you can build up caching on that compute cluster in memory. The easiest way to think about it is if I run a query for sales in January and February on the compute warehouse, and you come along 5 minutes later and run it for sales in February and March, the February sales data is already on the compute cluster. It doesn't have to go back to storage to get that data. So you will get better performance the more that data is used and the more caching you get at the compute layer. When the cluster suspends, you lose that level of caching and it has to be built up again.
Okay.
It's a very narrow use case where you wouldn't want to set your auto suspend time very low. And Tim, can you click on configure again? I just want to show this to everybody because it's an important feature in the UI. For anything that you're doing, there's a show SQL link down on the bottom left of that window. So you can copy out these statements and alter warehouse parameters in the worksheet programmatically as well. And here you can set the auto suspend to something very granular, right? You see there that the auto suspend is 300 seconds. If you wish, you can take this down to 30 seconds, 60 seconds to really get quick in when you suspend the warehouse.
Okay.
I wasn't even shown that during training.
You very quickly stop using the UI and the dialog boxes and very quickly flip over to,
all SQL.
commands.
Awesome. Cool. Thank you, Jordan.
Mhm.
So once you have those settings set, click Finish. And once you've done that, let's click back on the worksheet. And now we have all of the components in place that we need to actually bring the data into our City Bike database. So we are going to do a copy command, but first, go over here to the context menu again, and let's make sure that we have context set the way we want it, right? So I'm sysadmin, I'm using the compute warehouse, and now if you look, it's set to small. It's also suspended, but that's not a problem. It'll kick in because we have that auto box checked. And then if we needed to make it bigger, we don't have to go all the way back to configure. We could just hit the resize here, which I do frequently. And then make sure your database is still City Bike and that you're on the public schema. And then put your cursor anywhere in the SQL statement that says copy into trips from at City Bike trips file format equals CSV and hit run. So you'll see down here in the results window, there is a cursor that's spinning. So you know things haven't died. It hasn't hung up. It's doing its thing. And I can see that it's taken so far 29.8 seconds. Oh, finished. So that took 32.79 seconds to load. Okay, and I brought in 376 rows, right? So I can come down here and take a look at all of this down here in the results. Let's come over here to the very right hand side. You'll see this little arrow and it says open history. Open history, I showed you in the very beginning with the history button at the top, but this just brings it out in a smaller format. Shows us everything that we've run so far. And this is 32.79 seconds. You know, you could see the breakdown of how that came about and all that good stuff. Shows you the 61 rows, and it shows you how many bytes of data you brought in as well. So, and it also shows you the query that was run. Okay. You had one cluster, you ran that SQL statement. All right. Cool. Well, keep this number in mind. We can always come back to it, but it's not too big a number to keep in mind. So let's try something. We're going to change the size of our warehouse, but first let's truncate this table. So click anywhere in the truncate table trips statement there and hit run. Very quick. Statement executed successfully. It's gone. Okay. So go back to the warehouse. Actually, the way I do it is I go over here to the context and I say resize on my warehouse from this point. Make it large. Okay. Just make it large. All righty. And then we're going to come back over here to our scripts again, and we're going to run copy into trips from City Bike. It's all linear here. You don't have to go backwards. So just click in the script and hit run. How long will it take to load it this time? 10.89 seconds. So think about that. We went from small to large. We jumped right over medium. Medium would have given us double the power, and then we had double the power of medium when we went to large. And this took 1/3 the time that it took the first time. So if you left your history window open, you can actually see that here pretty well, shown graphically and in the numbers themselves. So that's really cool. All right, now we're going to move on to module 5 here, and we're going to look at analytical type queries, the results cache, and also at cloning. So I'm going to close my history down here,
Hey, Tim, before we move on real quick,
Yeah, sure.
I want to go back to the data loading piece because I think a lot of folks on the phone probably understand this, but it bears repeating. We were loading 376 individual files there out of S3 storage.
Yeah.
We scaled up through more CPUs at it, meaning we got more parallelization, which is why the load went faster. Something to keep in mind with the Snowflake computing here, when you're loading from files, one file cannot be operated on by more than one processor. It's just a limitation of the technology world. So if we were loading the same amount of data from a single CSV file, scaling up would not have given us better performance because a lot of those CPUs would be unused. So if you read through the documentation with Snowflake, it says things like chunk up your data to 50 to 100 megabyte files and create a whole bunch of files. That way, using larger clusters can take advantage of parallel processing and load your data in massively parallel format. So, I want to point that out because it is a sticking point. Sometimes you're like, well, I scaled up to an extra large and it ran just as fast as an extra small.
True.
That's true if you only have a single file to operate on. If you have many, many files, it will run much, much faster.
True, and that's the idea with the data that's stored on the S3 instance. It's 376 files.
Yep.
Okay. All right, so we're going to look at at some analytics type stuff, setting up our Snowflake environment for analytics. So the first thing that we want to do, first one is executing. So we've loaded data into trips, right? So the first thing we're going to do is take a look at the data that's in trips. But first, we might want to come over here, and we only have the compute warehouse. So we're going to have to go and create the analytics warehouse to work on. So go back up here to warehouses. Okay. And then click on create. And we're going to call this analytics_WH. All right, and I'm going to make my analytics warehouse probably small, like the others. Okay, it says to make it large, but I don't think you need a large. I'm going to set my maximum clusters on this one at 1. So I really don't need 2 clusters. I'm going to leave everything else at its default and click finish. And then I'm going to go back to worksheets. Okay. Over here in my context, I'm going to change my warehouse from compute to the analytics warehouse that I just created with its size large. Okay. So now we have, people can continue bringing data in really on the warehouse, on the first warehouse that was created there, and we're going to be happy as clams to do analytics because their importing of data is not going to affect our horsepower at all. I mean, they're totally separate. So when we were in the earlier session with all the slides, and Jordan talked about how we have the separation of the data layer from the compute layer, but then inside that compute layer we really have this separation of cluster from cluster, so they're totally independent. Nobody has to suffer from lack of horsepower, and nobody has to sit there with too much and spend too much of their resource to get it right sized for everybody. So the first thing we're going to do is look at that data that's sitting in City Bike Trips. So click anywhere in the select statement and click on run. And I'm going to bring my results window up higher. we limited it to 20 rows, so I can just pull up my results window here and see what's in here. So looks like I've got trip durations, start and stop times, station ID, a starting station and an ending station. I've got the longitude and latitude, so I know where those are at, and user types, all that good stuff. Okay, so got some data there. And the next thing that I'm going to do is going to come up here and, well, let's just see what happens. We're going to look for the basic hourly statistics. So this query is looking at how many riders there were per hour. So put your mouse anywhere in that statement and hit run. And we just did our first basic analytic query on the city bike data. And we can see down here in row one, we see for this looks to be between midnight and 1 o'clock, we had 152 trips. The average duration was 56 minutes, and the average distance was about 2 kilometers, not miles, 2 kilometers. And as we go through the day, we see the numbers up and down, kind of as you would expect. I was actually honestly quite surprised by the 152 at midnight, but it is New York City where they say it never sleeps. So that's pretty cool. We're going to run the exact same query again. And the reason we're going to do that, Jordan mentioned this again just a little while ago, but once a query has been run, I can run that query again. As long as it's the exact same query, I can run the query, Billy can run the query, Warren could run the query. As long as the query is the same and the data hasn't changed, it doesn't use any compute, which means it doesn't cost us anything. So I put my mouse here and I click and I'm going to go to history. Okay, and I want to show you something here. That query that took 1.23 seconds, which was fast to start with, is now only 173 milliseconds because all we did was take it out of history and just boom, it was in the results cache, so we just brought it back, and it's that quick. Now by default, that period of time I can do that is 24 hours. I can scale that up to as much as 90 days. As long as I'm on the Enterprise Edition or higher, we can do that. So really, really cool thing to do. So let's look to see which days of the week are busiest. What do you say? I'm going to close my history again just because I don't like having it open. That's not me. So I'm going to run this next select statement. It's the looking at days of the week. And I'm going to just click in the statement, hit run. I sound like a broken record on that, I'm sure. Oh, wait a minute. This was the one where I intentionally left the history open because as I open history further, it brings my columns closer together. And I could see without stretching my eyes across this 36-inch monitor and look at things. So this is ordered by the busiest day of the week. So Wednesday was busiest, followed by Thursday. Sunday was the lightest day of use, which I don't know. That makes sense to me if you're using the bikes to get to work. But if they're just for casual leisurely use, I would have thought Sunday would have been a busier day. But that's just me. I don't think like a big city person. I'm more suburban. Okay, so now we're going to we've looked at a few things in the queries and whatnot. So next, we're going to actually look at cloning. Okay, and when we're in Snowflake, as we've said a few other times, we talk about this zero copy cloning. All right. Snowflake allows you to create clones of the schema, of tables, and of your databases. And literally, it takes like seconds and you're good to go. It's just a snapshot. So it's not taking the volume, the storage, and copying it or duplicating it. It's just working with the metadata and pointers to create. It creates new blocks, new storage blocks inside that same data storage, not a new set of data storage. That's probably the better way to put it. So we're going to create a clone of trips, and what we're going to do is create one called trips dev, and I'll show you where we can look at that and everything after we run this. So if you click on if you just click on the query and then click on run, 779 milliseconds for me, and it has created this clone. Now, where can I see my clone? Well, if you look over here on the left, remember we had the all the objects sitting here, and if we just hit this refresh button, then under public and tables, we'll see trips and trips dev. Trips dev is that one that we just created. It was that fast. And we can go ahead and query on trips dev like anything else. Okay. So probably one of the best uses for this, at least in my world, because I'm a developer, is exactly what dev implies. It's for developers, maybe for test or quality control. Now the development guys can work on things, blow things up, create that darn Cartesian product without ever affecting regular production on the trips table. So, okay, so that is pretty much everything that we're going to look at on structured data. Okay, our next thing we're going to do is flip around and look at the semi-structured data. We're going to take a look at semi-structured data, starting with module 6. And if you'll go back to the original story, the City Bikes analytics team, they want to know. They don't just want to know which days have the most riders, but their question was whether or not weather, WEATHER, had an effect on the number of riders. And the City Bike database itself doesn't have any information about weather. So the weather set is coming from another provider called Open Weather Map, and they have historical conditions for New York City from July 5th of 16 through June 25th of 19. Okay, that data is also in the AWS S3. So we're going to be bringing that data in as well. And this time, instead of going through the UI and making all of these pieces that way, we're just going to stick pretty much to the statements. So things are a little bit faster to do. Okay, so with that said, we're going to get started. We're going to stick with the same context that we had before, and we're going to click on Create Database Weather and hit Run. That was quick, right? 66 milliseconds. So we created the database that's just, it's empty. Nothing there yet. So the next piece to do, we're going to look at we're going to go back to the context, because this is a loading function of data as we're building, as we bring data in for a table, to fill a table, bring on all this weather stuff. That is done in the compute warehouse, not in the analytics warehouse. Where we keep those separated so that the different types of jobs are not running over the top of each other. So set it to the compute warehouse, set the database to weather, because now we're looking at weather, right? And not public, or not the city bike. All right, and the schema is public. So the next piece here to do is to create this the JSON table. I did the context using the UI, and I'll explain that here. There is a spot in this coming along in this where if I run the query to set the context, it doesn't change correctly, and then it screws up everything after that. So I'm setting my context using the UI, and then doing the creating of tables and things like that using the scripts. So if you go to the script 6.1.3, create table JSON weather data, then hit run. And now we have a table created. All right. All good so far. All right. So if I go look at my databases, no, databases, tables. And we come down here, where are we at? I'm not where I want to be. Go here. Refresh. There's weather. So I've got weather here. And I go to public. There's my table right in there. I didn't need to go to that level with it, but that's where I'm at now. Okay. So next thing is creating the stage. We have the database, we have the table. Now remember from before, after database, we need stage, then we'll have file format, and then we'll bring data in, right? So let's go back to the worksheet, and we're going to create the stage. We'll click anywhere in there and hit run. Now we have a stage called NYC weather. All right. And we want to look at the contents of that stage. So we're going to come here and say list at NYC weather and run. And this is the contents of the stage, right? So we've got all these files that are going to be coming in from the S3 world as we go. And so we've done that. Now we need to create a file format. So we've got copy, no, right? Where are we at? Copy into JSON from, no, I think I made a slight mistake. Let's see here. No, we're just copying. So copy into JSON weather data from NYSync weather file format equals type JSON, okay? And we could have manually gone and created that file format, but which is listed right here, but we're doing it with the queries. It's just that much faster. So we don't have to mess around with it. Okay. And then after doing that, let's take a look at that data. So click on the select statement and then hit run. We're going to bring in that first 10 rows, and I'm going to bring my results window up higher so we can see this. Looks interesting. If I click on one of these rows, it opens up the details. And if I scroll to look through this, I could see that this JSON data is pretty much what name value pairs it looks like to me, right? I could be wrong, but that's what it looks like to me. So after you've taken a look at that, just click done. This data is now in our database, okay? So we're going to create a view so that we can query this data, all right? So one of the really unique things about Snowflake is that we bring in this. We started out, we brought in all this structured data, right? All this stuff that's in your regular everyday kind of table structure that we all know and have used forever. And then we bring in this semi-structured data that doesn't look anything like the structured stuff, but in the end, through the wonderful world of Snowflake, we're able to write an ANSI standard SQL statement that queries this data joined with the other data like the two were the same format. It's astounding. It's a wonderful thing. So let's take a look at how that goes. Where am I at? I am on 6.4. Did I roll myself backwards by mistake? I did. So we're going to create this view of the data, and then well, click in there and we'll see how it looks. I can talk too much. I'm well aware of that. So the statement actually ran very quickly. It ran faster than I could actually get to my notes, which is nothing unusual. So come over here, and if you don't see this view already over here, then refresh on the left-hand side, and you'll see the JSON weather data view down here at the bottom. We're going to take a look at what this view looks like now. Okay, so I'm going to query. We'll just query this just like any other. Look at the statement, select asterisk from JSON weather data view where data trunk, we get the month, observation time. So we're looking at 1/1 of 18, and we're gonna look at the first 20 rows. That's everybody's everyday bread and butter SQL statement that you learned in the very beginning. Whoops. Let's see here. What have I done incorrectly? Did I not click inside of it? Yeah, I forgot to click inside of it. Okay. So in a sense, I tried to create the same thing twice. Not good. Okay. So now look at this data. We went from it looking like these name value pairs, and Snowflake has taken this data and given us a view that is wonderful. So I see I'm in New York. I've got the lats and longs, cloud cover, temperature average, temperature min and max, the weather, whether it was snowing or raining, mist, all that good stuff. And it's all right there. Even wind speed. I mean, come on, wind speed and direction. So all of that weather data is in there now. Well, what do we have left to do then, other than bring it all together, right? We're going to join the two databases or two tables together. So we're going to get trips, and we're going to bring that together with the weather. And wow, that is just wonderful. Okay. So let's see here. Clear. Number of trips on clear days is 9.2 million trips on clear days. Okay, that's our highest. And then when there's smoke in the air, we're down to 2871. I guess smoke, I don't know if I call that weather, but haze is definitely weather. And that's 40,727. So ultimately, we have answered the question here. Does the weather affect the number of rides for City Bike? I would think you'd have to say yes to that, right? All right. Well, we answered that question. So let's take a look at some of the other capabilities that can be that are part of Snowflake. First of all, we're going to look at time travel, and I'm going to readjust my screen and stuff like that. Um, so I'm going to start off here showing you in time travel. I'm just going to say, well, suppose I made this hasty decision to drop this table. I don't need the weather data anymore. I answered the question. So I say drop table, JSON weather data, and I hit run, and boom, it's gone. Um, let's just prove that it's gone by running that same select statement we had earlier that said select from JSON weather data, and we want the first 10, and you'll get this error. It says the SQL compilation error does not exist or not authorized. Well, in this case, it does not exist. But through the beauty of these unmutable blocks and what Snowflake calls time travel, I can go back to my results cache and I can say, hey, wow, I goofed. Undrop that table called JSON weather data. So I click on that query and hit run, and I see there's success, one row there, awesome. So in that way, I can bring back that entire table that I just dropped. It put the whole thing back to the point where it was before I went and screwed up. Okay. Well, let's check our roles here, our context here before we move forward for the next example. I'm going to go in here. I'm still sysadmin. Now, mind you, I am using the UI instead of the statement, and this is where I've run into trouble when I use the statement. So um, I'm going to just make sure I use the UI. Sysadmin warehouse is compute warehouse. I want to switch back to city bike, and I'm still in public. Okay, so that's that part. And then hypothetically, this is that where I've got my I've got my intern, and they are not quite paying attention. Knock over a can of Coke on the desk where it shouldn't have been to begin with, and accidentally change the name of my stations to oops. So I'm going to update my trips set start station name to oops. Okay, so I went through and it changed them all. Took 5.96 seconds just to be sure. I'm going to go and take a look here, and I should get all of my stations and their names here. And we'll find that we get one station name called oops, and all of my rides are now part of oops. So bye bye to all those other stations that I had. All right. Well, once again, by the magic of time travel, I can go back and actually fix this problem. So what I'm going to do is I'm going to grab the query ID from that query, and I'm going to use that to go back. So I'm going to be looking for update statements, and let's just put our cursor in here and hit run. It says here that my statement executed as it should. And let me just make sure that I'm not missing something. Okay. So now we're going to go in here and say set query ID. That was the one we just ran. Now we're going to say create or replace table trips. Okay. So the last time we did create or replace a table, that was when we created the weather. And the first time we did it was when we created trips originally. So now we're going to replace trips. It's already been created, but it's hosed. So put our cursor in there and click on run. It says trips created successfully. That is awesome. Now let's run that query that showed us the oops again. Hit run. And lo and behold, I've got my Pershing Square, Broadway's there, Lafayette, 31st and 7th. I've got my stations back. So time travel saved my bacon twice. I mean, that's cool. And then think about those the challenge that Jordan put down earlier. Do a clone and a time travel at the same time. So say go back, 30 days, make a clone from data that's 30 days old and or do a clone and then do a time travel 30 days. It can be kind of confusing at first, but definitely have to give it a try. It's really cool. All right, so we are ready at this point to take a look at module number 8.
Quick question.
Sure.
This is Cedric.
Yeah.
When I'm looking at the statement that was used for the time travel, it looks like it was based on query ID, which you found based on searching through the query text. Is that is time travel specifically done based on that statement, or are there other like keywords that you can use other than statement?
Yeah, I could look for the timestamp, and I could look for a range of timestamps in reality. I could look for just date or date and time.
Okay.
Yeah, there's any number of ways I could do that really. And I don't just have to look for update. I could look for, I mean, maybe I did a lot of different updates, but I know that this update had to do with stations. So I could search for that field as well.
Okay.
But the ones I see most commonly use a timestamp. At least the examples that I look at. So, Jordan, do you have any other input on that question?
Yeah, I mean, the simple answer is you kind of have 4 different options, right? So you'll see in this case, we're using a before and a statement ID or a query ID. You can also do after a query ID. You can also do, well, I guess it's not before and after. So you can do before, the millisecond before a statement was executed, the millisecond after a statement was executed, or any absolute time. So you can look at a table as it was at 12:01 a.m. and 14 seconds.
Gotcha.
That's how
both work.
That's how I look at it.
Okay.
Thank you. Sure. So we're going to look at roles-based access controls. So we're going to move things around a little bit differently. We're going to set our role here to account admin. So in the we're going to start out here. If you right now we're sysadmin, right? That's our role in the context of things. So I'm going to run this query here. Use role account admin. I could just as easily have gone over here to the UI and changed it there. It's just a simple matter of going to role and clicking on change and choosing the one that I want. Okay. And now what we're going to do is say we have a new guy that I keep picking on the new guy, right? And we're going to call him Junior DBA. So now that we're calling him a DBA, you're off the hook, Billy. Just kidding.
I love to hear it.
Just kidding, man. I know you can handle it. So we're going to create a role called Junior DBA, and then I'm actually going to assign myself to being Junior DBA. So if you look at the second line on here where it says grant role Junior DBA to user, you're going to want to put in your username that you used when you created the account. The same name that's up here in the top right-hand corner of the screen that says Tim, and then underneath it says sysadmin. So if you created your account as Billy, you're going to put Billy there. And since there are two words, make sure you erase the second word, because I think it says like name here or something like that. And I kept leaving the word here and there. And like, why do I have an error? You know, that's kind of like that searching through for a needle in a haystack, only this needle was huge, like a knitting needle. So click on that after you've put your name in for the user and hit run. Yeah, let's see here. Role Junior DBA does not exist or not authorized. What did Tim do wrong? Let's double check. Yeah, DBA, yeah. I think I did it right. Operation while in a role sysadmin, it would fail due to insufficient privileges. Yeah, I bet it ran. Nope. Let's go up here for a moment. Change my role up here. Okay. Now let's try it. Now I gotta scroll all the way back down to 8. All right. There we go. Okay. So the error that Tim created was that it was not the account admin here, only here. So I didn't have the privileges that I needed in order to successfully create the role of Junior DBA. All right. So now I'm going to go over here and I'm going to change the context. So instead of account admin, I want to change to.
I think you need to run your grant statement. You need to grant the role.
Yeah, that's right. Brr. It's because there's no space between them. I have done that twice. Thank you, Jordan. Now, if I go up here to the context and I say change, I will find Junior DBA, right?
Should. Just run the next command, use role Junior DBA.
Yeah. Hey, it switched it. All right. Well, that was interesting. Okay. So that was very interesting. If I look over here on the left, okay, and I refresh, now you'll see that you'll look over here and you go, well, wait a minute, what happened to City Bike and what happened to weather, right? But those access to those databases has not been granted to the role of Junior DBA yet. So they're not going to have access to that. So the next thing is we're going to change the role, but our role back to account admin, because only the account admin account can put in these users and grant these privileges to them. So the first thing to do is click on use role account admin and hit run. And I'm now account admin again up here in my context. And then I'm going to click on grant usage on database City Bike to roll junior DBA and hit run. All right, and then the same thing for weather. So click in the SQL statement and hit run. Ran successfully. And I'm going to change my role again so that I am now junior DBA. So use role junior DBA. Okay. All right. I see weather. I don't see the schema in weather. I see city bike, but I don't see anything there. Oh, here we go. I just didn't refresh. Oops.
Junior DBA doesn't have schema rights to public.
Right. So we have to give them all that stuff. So once again, we're going to change the role. This is how tight we can be with security on Snowflake. And my brain doesn't always think to this level. I'm like, hey, there's junior DBA, throw them in there, you know. But Snowflake is big on security. Then we're going to use our warehouse compute. Then we use the database weather, and we use the schema public. Okay, I'm going to refresh over here, and now you will see that junior DBA can see all of this in weather. All right, so that is the just a really quick. I mean that is a just really quick example of the security type stuff that barely scratches the surface on this thing. So let's look at some other stuff that you can do in the UI. If you go up to the top right hand corner and you click right there under your name, switch the role. If you haven't already, make yourself the account admin, because there are other things that only the account admin can get to. I know the first time that I ever got into Snowflake, and I didn't read any of my documentation and whatnot, and I was like, why can't I not get my Tableau stuff? Why can't I see my account usage and stuff for my Tableau dashboard? Come on. But if you're account admin, you have this button here that you didn't have before. Button number 7 for account, right? So if I click on account, then I have things like usage, which it defaults to. And so I can see my I've used 9.39 credits on compute, 4.4 on the analytics warehouse, nothing on the cloud services. Cool. Oh, I have 3 warehouses, all that good kind of stuff, right? I can see the billing information. So if I want to click there, it's a freebie. There's nothing out there. If I want to continue beyond the use of this free 30-day trial, basically you've got $400 worth of credits, right? So if you blow through the $400 in the next 24 hours, you're pretty much done. But you can come in and add a credit card and keep on going. You know, that's one of the cool things about Snowflake too, is that you know, there's not a lot of upfront kick in. If I'm just wanting to approve something out and I've got an expense account to do it, I can go ahead and do it, right? I can see who my users are, my roles that are out here. You know, there's that junior DBA guy, and account admin owns the junior DBA guy, right? So that gives us all this ability to see things that we couldn't see things before. So just another piece of that security in there. All right. So we're going to move now to data sharing. and we're going to stay in the account admin role for that. Okay. So, Jordan, at this point, do you want me to go ahead and do this part of the data sharing, or do you want to kick in and talk about the shares and data marketplace and all that kind of stuff?
Why don't you go ahead and do the data sharing quickly,
Okay.
and then I'll wrap it up, because understanding how the data share works in an A to B type of world
It's important.
will inform the the bigger picture here.
Right. Okay, cool. Oh, hey, one other thing real quick before I go into these other things. If you would like to do this all over again by yourself at another time, at the bottom of the script was all these drops. If you run the drops, this whole thing will be back to square one, and you'll be able to start over and just create from scratch on your own. So have at it. All right, so we're going to take a quick look at the sharing piece here. If you're still out here in account or wherever, if you click on the snowflake up in the top left corner, you'll get your left menu back, and you'll see the snowflake sample data. We're going to click there, and we're going to go click on shares. And so we see here we do have this account usage share, and then we have the sample data sitting there. That account usage share, that's the one, if you take a look at the sample Tableau or PBI dashboards, you'll be using the data from there to create the visualizations of account usage. Okay, so let's click here and look at and these are our inbound shares, but let's click on outbound and see we're not sharing data outbound at all at this point, but we can. So let's look at that, and we'll hit create. Okay, and so we're going to create this secure share name. We're going to just call it trips_share. And the database is City Bike. Okay. The tables and all that good stuff. If you click there, you'll go to City Bike, and then Public, and then Trips, and hit Apply. Okay. And then we will hit Create. Okay. Now, we've created a share. Okay. The next step, if we were going to go all the way through with this, we would have to go through now and then and give access to users or people coming in to grab our outbound share data, and we're not going to do that right now. So rather than say next add consumers, and I fail to use that term consumers all the time, we're not going to add consumers, so we're just going to click done. Okay, and so we've created this share, this A to B share, as Jordan calls it, called Trips Share, and it's just going to sit there, and it's not going to have any activity on it because we have to assign consumers before it's available to anyone. Okay, so that's that part. That's the A to B sharing that he's been talking about. And now Jordan is going to show us the data marketplace.
Yeah, so if we can stay on the screen for just a second.
Sure.
So the last piece here, whenever you click add consumers, a share is between Snowflake accounts. I think that's an important thing to note here.
Sure.
And obviously, as Tim showed, the share can be an entire database. It can be a single table. It can be a secure view. It can be a set of secure views. You define the objects that go into the share. But once you share those shared objects, you share to an entire Snowflake account. So if you look in the URL here, the account that he's using is SX67358, right? That is the account. So when you would set up a share, like to me, my share is demo 62, right? It's just the one I'm going to use. So if you wanted to, you could add consumers, demo 62. Don't do it right now because it'll mess up my next demo, by the way.
Okay.
That would initiate the share, and then I would pick it up and do whatever I want with that share. And I'll kind of pick it up from the data marketplace here in a minute. And then I, as the recipient or the consumer of that share, I get to set my own role-based security around the share. So if I only want to share the data that if I only want to expose the data that Tim's sharing with me to a specific role in my organization, I can do that as the consumer as well. So it does get very granular in how we can control this data. This should be a pretty quick thing, but it's a very different way of looking at how we share data and how we do things and think about analytics. So notice I jumped into my demo 62, right? This is me. So what I'm going to do is act like, right, an analyst at City Bike, right? And City Bike makes money obviously by renting bikes, but they also have an awful lot of data around where people are at any given moment, where people are moving to and from. And hey, retailers really like that type of stuff, right? They want to know that stuff. So we have the data that we've been looking at, right? I've got information about trips. I've got information about weather. Wouldn't it be really nice to know when somebody ends a bike ride with us, what may be nearby that station where they turn the bike back in for them to potentially go do, right? I don't own that data, but it'd be nice to have. Well, hey, guess what? A lot of that stuff is out in the data marketplace. So, if you want to play along, click in data marketplace and then click the explore data marketplace. The data exchange and data marketplace all runs in the new Snowflake UI. So it's actually a little bit of a different UI experience. But this is that global public marketplace where a lot of our customers are pushing out, public data sets or de-identified data sets that they just want to get their logo out there, or they want to potentially start a new business relationship with other Snowflake customers. So you'll see a ton of tiles out here, right? There are hundreds of these, right? And it's growing every day. And we categorize them all across the board. Here are some of our biggest featured providers. FactSet, S&P. S&P is a major provider. SafeGraph, which is the data set we're going to use. You can go look for this stuff. IP geolocation, maybe that's meaningful to somebody. It's here, it's available. You can go try to use it. The personalized piece generally means that you need to have a relationship with the data provider. So they will give you a share specific to you. So what we're really looking for are the ones that are totally open, right? So if you need foreign exchange rates, here's somebody that updates that data all the time. It's updated hourly. You can go get this foreign exchange rate data set, and every hour they will update all the exchange rates for you. You don't have to do anything to get that refreshed data, right? It's just magically in a database and you can do your exchanges. So I'm going to go back. The one that we're going to use is in the local category. So if you click on local, it'll strip this down. We have a lot of OpenStreetMap type of data that I have not played with, but the one that we're looking for is this SafeGraph data set. You'll notice it's not personalized, so it's the same data set for everybody. But it's a point of interest data set, right? And it's specific, it's slimmed down to Starbucks, right? What SafeGraph is doing here is they make the Starbucks data publicly available. As an analyst, I think that's interesting. I'm going to go grab that data set. And if I love this and I want to know not just where Starbucks is, but where all retail establishments are, I can contact SafeGraph and they will gladly sell me the larger data set, right? See how this works? So I'm going to start with Starbucks, and maybe that's interesting, right? So I click on the tile, you get some information. Generally speaking, there's a data dictionary in here, right, that they'll send you to a place where you can figure out what's in the data sets, documentation around all the data listed, and they'll give you a couple of things that, you know, like these are the types of analysis you can do with this data set. Okay, I think that's interesting. All I have to do is click on Get Data. Right? It's going to tell me what the database name is. I can change this if I want to. I'm not going to. I'm going to leave it just like that. And then I get to secure within my environment who gets to see this shared data. So by default, I have a role called Exchange. I'm going to set this to Exchange. If you're following along and doing this, you probably want to click on sysadmin because we've been using sysadmin for everything in the demo. So click on sysadmin. Anybody with sysadmin privileges will be able to view this database. I accept the terms and conditions of taking this data and create database. Instantly, I now have access to that information. So here are the two tables that they're sharing with me. SafeGraph is storing this data set, and I'm simply reading it in SafeGraph's Snowflake environment. It was that quick.
And
If
you're
I go
paying
back
for
to
the
my,
compute, right?
is there a question?
You are paying for the compute?
Right, I will pay for the compute.
Okay.
So I click here, you'll see that my new database has shown up, right? I'm operating as the Exchange role. So I now have these couple of tables, not paying for storage, but as soon as I start querying these, I pay for the compute, right?
So as of now, you still haven't paid anything.
I haven't paid a thing. Nope. Got access to the structure. I now have an open connection into the data set, but hasn't cost me a thing until I start querying it. So first things first, right? I'm going to look at some of my data that I own. And I'm going to do some geolocation stuff because this is fairly new to Snowflake and geospatial. But I'm going to look at my trips, and I just picked February for a month, right? I'm going to look at all those trips in February, and I want to see how many trips ended at a station at a specific Latin long at a specific point, and just see what the most popular ones are. I'm also using this geospatial function that will create a geospatial data type, right? So I run that. So I got my data set back here, and it tells me, you know, I did 1,500 rides to Lexington Avenue and 26th Street. And here is the geospatial data. Snowflake handles geospatial very different than most other tools. The reality is it's all in semi-structured format, and we can handle GeoJSON, which is this. If your customers have data in well-known text or well-known binary, we can ingest those natively as well and use all of these same functions. So we handle all three well-known geospatial data types without having to really do anything other than put it into a geographical data type. So I've converted a lat long, that's just numbers, into something that is coordinates. And so I know where most of my rides end. That data I already had. That's not interesting. Here's the new data that's coming from SafeGraph, right? I looked at Lexington, right? It seems to be where there's a lot of rides. So I'm going to look at for all Starbucks on Lexington Avenue in New York City. Limit 100. I don't think there's more than 100 Starbucks on Lexington Avenue. I'm right, there's 12, right? So this is the data that I don't own. This is the stuff from the share. And I'm querying it directly. So I've now found the 12 Starbucks on Lexington Avenue. Okay, great, that's cute. But let's do some analysis on that, right? Let's look at, and these are just copies of the two queries I ran above. Let's look at my station locations for my rides in February, along with the locations of Starbucks along Lexington Avenue. And let's join that data together and look for Starbucks and End City Bike station locations that are within 1 mile of each other. So that's what this ST distance is doing. It's taking those two GeoJSON points and calculating a number of miles. And I want to see every place that's within 1 mile. So if I run that, it's going to do all my geospatial stuff, and it's going to say, all right, here you go. For all 12 of those stores on Lexington Avenue, here are the City Bike locations and the distance from that Starbucks address. So the stop at 53rd and Lex is 0.01 miles from 599 Lexington Avenue. Lo and behold, that's a Starbucks. Hey, pretty cool, right? I just found out something about my riders and the areas that they're dropping off bikes. Maybe they want a coffee, right? And I have the points here if I want to map them. So what I've done is taken data that I don't own, taken data that I do own, jammed them together, and done some analysis that I never could have done in my own environment. Very cool. And that was live. That is how long it takes to get a data share from the global data marketplace. It takes 2 minutes if you find the data that you want to go after. So I think this is interesting. I'm going to take this query and these results. You know, again, you could find stations and Starbucks that are up to a mile apart. And I'm going to throw it in a view, whatever. And now I'm going to expose that view to my analysts and let my analysts go figure out what marketing campaign we're going to run with Starbucks, right? So now I'm going to take a look as an analyst at that view I just put together. The analyst doesn't know or care where the data is coming from. They want to know, 511 Lexington Avenue is a Starbucks. Give me all of the rides that happened in February that ended less than a quarter of a mile from that one location. Great, there we go. So there are thousands of people in a month that stop a bike ride less than a quarter of a mile from 511 Lexington Avenue Starbucks location. Now, what I do with that, I don't know. Maybe we take this data to the owner of that franchise and say, hey, wouldn't you like to send a text with a 10% off coupon for coffee at your location when they stop their bike ride? And here's how many people do that in a month. And here's how many impressions you can get for people that are within 2 blocks of your location, right? That's the stuff that, when people hear public exchange and public data, it doesn't seem all that sexy or interesting, right? It's public data. How valuable can it be? That stuff right there is hugely powerful and hugely empowering and enriching to, to folks that just generally don't want to go find these data sets, ingest them, put schema on them, worry about loading the data, worry about getting updates to the data. This is live. So as soon as a new Starbucks location opens and SafeGraph gets that data, it will pop up in my data set because I'm live reading via this view to the shared data from SafeGraph. If this data was updated hourly, something like the exchange rates, that view every hour when new data got into that table, my view would instantly reflect it without running any ETL, moving any data around, and all of a sudden I have a little bit more capability than I had before.